Hi everyone. Can you hear me? Can you see me? Hi everybody. Thanks so much for coming. Thanks for joining. I can see the chat feed here, and as you'll see, Corey from our customer service support team, he's going to be managing the chats there. So if you see Avid CNC, that's Corey. All right. Awesome. Thanks everyone for coming. Where's everybody from? I see we have Canada, already international live stream. That's great. Egypt, awesome. Cool. We got some Washington, local Pacific Northwest. We got some Texas, San Diego. Got some sunshine from SoCal. Atlanta. We were just in Atlanta last fall, or fall. It was a few months ago for Workbench Con. Awesome. Cool. So if you don't know, I'm calling in from Portland, Oregon. I run our Portland shop, which I'm the only employee here. So everyone else is based out of North Bend, Washington, small town outside of Seattle. So calling from the Pacific Northwest. Does the sound okay? Everything's good. Get some thumbs up. Got some Vancouver, Houston, awesome Michigan. Whoa, welcome everybody. Thanks for joining. We'll just wait a few more minutes before we start any kind of presentation thing, but this has been really fun to be able to do some live streams to connect with everybody. I know this is a strange time, but we're going to be really creative and be able to get some education and CNC work holding topics out there and all sorts of things. So I'll mention that next week, Corey is going to be leading a talk or a tour of Mach 4, which is the controller program that we've been using and the one that we recommend. So if you want to learn all about Mach 4, and if you have Mach 3 and you haven't switched over yet, you might get to see some features and reasons to do that. Oh, hey, Bernie, what's up? Awesome. Cool. Awesome. Izzy, how's it going? If you guys haven't seen, Izzy's making this really cool, I don't think it's an aeroponic system. I think he can tell you more about it, but there's this awesome folding bookshelf table planter system. It's so awesome. I'm going to have to make one myself soon. Awesome. Thanks everyone for coming. Cool. So last week we had a stream all about, oh, cool. Okay, sorry. I have to learn to balance with the chat here, but we'll have to try to do these live streams weekly and for the next few months, and we'll see how that goes. If there is continued interest, we'll keep doing it. You can see I went to go pick up my workbench this week from the shop. I don't have a machine at the house yet, but hopefully soon. So I'll get to show you some live cutting, hopefully really soon. It's great. I used both Works by Solo and Izzy Swan as references in today's talk. Hey Stu, what's up? Awesome. So I'm going to give a presentation about different kinds of work holding. I hope that this helps inform the choices that you want to make for your specific projects. There are so many variations for every kind of work holding, so I'm going to cover the basics of each type. If you have specific types of clamps or files that you want to suggest that you've designed, please go ahead and feel free to put that in the chat or in the comments on the video for folks who are watching this later on. So please do share your thoughts on the type of work holding that you like to use. I'm going to share briefly going through a bunch of different sections, so we'll get to talk about that. All right, so I'm going to switch over my screen here to presentation. Cool. Okay, so here we go. I'm going to just talk a little bit about the kinds of work holding that I like to primarily use, and a few others. I have a lot of examples from many of our content partners and other content creators. I have a work holding playlist that's linked in the description, and also links to the different channels that you might reference. So I gotta switch over my screen here. Okay, so you can see, just confirm you can see that. Okay, perfect. So a little bit about me. My name is Sammy. I am the digital fabrication media producer. I do all of our creative direction and media production. So I make our YouTube videos. I, do some of our, graphic design and that kind of thing. Do some CNC curriculum development. So my background is in sculpture and in digital fabrication. I study sculpture with a focus in digital fabrication at the Savannah College of Art and Design. And then after moving to Portland, I got a job as a CNC technician, worked in digital fabrication project management, and managed a fabrication team locally. I also wrote and taught CNC courses, which I taught weekly for a couple of years. And I'm still working on a class for a local PCC, Portland Community College. So hopefully that'll be a workshop that's available, I guess, now in the fall. So my job here is a really great collaboration of making and education. Oh, hey Dave, awesome, thanks for joining. So making and education are my two passions, so that's kind of where this is like a perfect job for me, and I absolutely love it. And this part is bringing community into it, which is also something I love to help build up. And I will mention again, Corey is in our comments. Corey is our customer experience manager. So he and I will both be sharing host responsibilities here. I also will show you my other co-host down here. This is Sparky. Sparky says hi. Cool. Can you hear me now? Okay. How about now? Awesome. Okay. It seems like the sound is back now. Okay. Awesome. Thank you all so much for your patience. This live stream thing is really new, I think, to a lot of us, and we're still working out the kinks. So I have a lot of connections for my computer, so we'll blame it on Sparky. Okay, great. Now you know a little bit about me, and y'all are familiar with Avid already, so we'll talk a little bit more about our mission later on. So work holding is really just referring to any kind of device that's used to secure a workpiece against for the cutting forces of the machine, which is a very simple, vague, broad type of definition. And it's a good thing because there's so many different options and choices that you can pick from for your specific project and different kinds of oh yeah, sorry, there we go, perfect. So there's a few ways I'm going to rate the work holding so that it can kind of give me a guideline on what is right for my project and different ways to kind of perceive what is the strengths and weaknesses of different kinds of work holding. So the speed of use of the type, how fast it is to set up your workpiece, how fast it is to release it from the bed, how fast your cleanup is, Another one would be trust. Like, how robust is it? Do you really trust your work holding? I think it's a very important thing to benefit, the cutting quality, the stiffness of your work holding really will affect the product and the outcome, right? Another one is risk of failure. Like, what is the potential damage to the workpiece, to the work holding, if you're using clamps, or to the router bit, and then mostly to you. Like, how safe is it for the user? Another one to consider is the repeatability. Sometimes the work holding is something you're only going to use one time, and sometimes it's something that you want to repeat and have for high volume, quantity of products. So up here I have on the corner, I've made probably 15,000 tab handles in my career as a CNC technician, and for various different local Pacific Northwest breweries. This particular one is for a Zoigl House. So in order to increase your profitability, you want to make sure you have really high repeatability, and work holding is a big part of that. Another thing we should consider is the initial investment, and that is a couple different things to measure that. That would be in cost, like how much does it cost to to purchase clamps or vises and that kind of thing. Another one would be, how long does it take to design and fabricate your jig or your fixture? So that is something else to consider, is your time is also valuable. Here's my little way that I'm going to rate my different kinds of work holding. So just look for those different measurements. You might disagree about specific things, but this is kind of just a quick way to rate them and kind of pick which one is right for you. Also, different variations within categories are going to vary. So there might be more variables that this might not be able to capture quite that way, but it is a good place to start. So we're going to go through each technique and break it down, kind of identify what kinds of projects you might use that work holding for. What are the pros and cons of each type of work holding? What are the variations? And then we'll rate them also. So these are the categories I've kind of identified as very common work holding techniques. Tabs is one that I have a lot of opinions on, and it's a really great tool if you use it correctly. Adhesives is another category. Fasteners, clamps, fixtures, such as a vise or custom jigs and that sort of thing. Live edge and organic objects are a little bit difficult to work hold, so that's something we'll touch on, as well as the rotary axis. Okay, so first starting out with work holding with tabs. This is something very simple and fast and easy to program. I think in VCarve, if anyone here uses Vectric or Aspire, you can place the tabs yourself. And I think it's a lot better to place your tabs yourself rather than letting it auto-generate, because you're going to be able to be very strategic with your placement. So let me explain what I mean by that. There is another video about tabs in the let me just move the cat really quick. So there's a couple different kinds of places you can put the tabs to benefit your work holding. So I'm going to point out to the rectangles on this piece in the bottom corner. You can put the tabs parallel to the grain here at the rectangle, which the tabs are kind of like little bridges that hold the part to the drop material. You can also put the tabs perpendicular to the grain, like on this bottom rectangle. And the difference is the top ones are going to be very strong because it's going with the grain. And the other ones going perpendicular are going to be easier to remove because when you cut it with a chisel or whatever cutting tool that you prefer, it will split right on the grain. So that's easier to remove versus stronger. So you might weigh those options based on what your project is, the kind of materials you're using. I would say that this is something you might use in most projects. You can see up here on this image is one of my first double-sided 3D carved objects. It is a canoe, so you can't see the scoop, it's on the other side, but tabs are very important. You want to make sure they're really strong so you have really good rigidity if you're doing a 3D carved object. The one issue with putting tabs parallel to the grain is that it's more likely to tear out. On this bottom right corner, you can see that there is potential for your workpiece to tear out on the back of your work, and that's not ideal. There's several different kinds of ways to clean up your tabs. You can flush trim or use your sander. So I would say that I do really trust my placement of tabs when I'm being thoughtful about taking time to put them where I think they should go. It's medium speed because I do have to take time to do that. The removal time, I'd say it's slower because you have to flush, trim, and clean up all the ones that you placed. The repeatability is really high because once I have them programmed in the file, they're there and I don't have to worry about placing them every single time. And the initial time cost is higher, but there is not really any financial cost to me. So this might be something that you obviously use in tandem with another kind of work holding. It holds your final piece to the drop material. So now on to adhesives. So there are a couple different types of adhesives I'm going to talk about today, and there's different strategy combinations that you might prefer. So feel free to share that in the chat if you have a particular method that you prefer. So the first one would be just a double-sided foam tape. This is really not something I prefer to use, but it does have a place where you would put your workpiece and then the foam and then the spoil board sandwich. It's something I would use on smaller work pieces and projects that require full access to the top surface of the material, whereas rather than having a hold down clamps where my router bit might need to go. I think it's very fast and easy to set up. It's cost effective, not that expensive, but it's for a very particular type of project. I think that foam tape is kind of annoying to remove. There are some ways to get around that, which I'll talk about in a minute. The repeatability is okay if you have an L-shaped block or dowel pins in your spoil board, something square to line it up against. It's pretty easy to repeat if you put your workpiece against that edge. So there's just some things to consider. Another variation of this would be to do workpiece, blue tape on the bottom of your workpiece, super glue, blue tape on your spoil board surface, and then sandwich those together. I'm not as patient with things drying, so this is not usually my go-to. So a variation of that I prefer would be to put blue tape on the bottom of my workpiece, which is something I want to protect from the really sticky adhesive from the foam tape. Do workpiece, blue tape, foam, and then onto the spoiled board. And usually foam tape is pretty easy to remove from MDF because of the texture and quality of MDF. So, all right, here we go. Another trick, this is one of the very interesting methods that I don't think I normally would have thought of myself, but it's something that you would discover after trying to cut sheets and sheets of foam. So I'll credit this to Thingergy, which is a fabrication shop outside of LA. They make lots of movie sets and costumes for Hollywood and that sort of thing. Owned by Frank Ippolito. He had many appearances on Tested, if you're familiar. So go check out Thingergy. We have some great videos with projects that we did with them. So the solution here is they just have 6-inch tall foam and they need some way to hold it to the bed. So they can carve 3D forms, which they use for various types of projects. And the solution is a very simple one, and it kind of shows you that you don't always have to over-engineer every single thing in your project. all they would do is take masking tape and tape it along the edges of the material to the table, which is a very simple solution, and it's something that I kind of wish I knew about earlier. So if we just look at the ratings here, they trust it because they're running this machine 40 to 80 hours a week. They run overnight 20-hour passes or whatever they have to do. The speed of setup is so quick, it takes 2 minutes to attach this large piece of foam to the table. The removal is super easy. There is no cleanup. The repeatability is really fast because you can see they have their stop blocks set up, so the zero doesn't change. And the initial time cost is next to none, and the initial financial cost is also non-existent. So this is the ideal balance of something that, if you're doing many things, this is kind of where you want to be on your rating system. I don't really have any cons to this solution, but if you have some opinions about that, please share. And here you can see that they're not using a shy router bit. This is like a 6 or I think maybe even an 8-inch router bit. So they're using, albeit it is foam, but there are, there's still a lot of machining going on. So, and they have tried and tested, it's very reliable. So that's great. And this is also cool. They originally had this second Z set up for plasma, but when they're not using plasma, they just attach their dust chute to it, which is kind of cool. All right, so this is a solution I would have preferred to have when I was making architectural models for local firms in town. So this is, something that took me, I don't know, maybe 6 hours to run, and it's sign foam, so it's very expensive. I can't have it fail. So you can see here I use stop blocks, but the masking tape probably would have been just fine and a far easier solution. Okay, so this is one of my favorite work holding solutions, is the composite nail gun. And this is a pneumatic tool, so you just have to have your air compressor set up to use it. It's just like a brad nailer, but it shoots plastic nails. And I'll tell you why that is a really great thing to have. It's because you are able to cut through it with a router bit and not do any damage to your cutting tool or to yourself or anything like that. So it's really nice that you're not cutting through metal, you're just cutting through plastic, and it's sandable and paintable, and it's really fast and easy. I think this is a really great tool. I know Izzy uses this a lot. This is great. If you want speed, this investment is going to be worth it for you, because it is it is a tool that you have to buy. It's pretty unique. I wouldn't recommend putting the plastic nails in your regular brad nailer. They just don't work quite the same way. There's a few mechanisms that are different, but it's something I really trust. The setup is really fast. The cleanup is easy. It's repeatable. It does have a little bit of initial investment in terms of cost, but it'll save you so much time later on. It's almost negligible at that point. So here's like a project that I might use use my composite nail gun with. This is a display for a local pop-up shop, and because I know that I'm cutting out parts, I know that I'm not cutting within 3/4 of an inch of the edge. So that 1/2 inch around the edge is a safe place to put my brad nails or my composite nails. So I can just shoot around that border, and I really only need, for a full sheet, I probably only need 8 or so. Then afterwards I can just tap the side with a mallet and they just break off, because they have a really high shear strength and a really low tensile strength, or maybe it's flipped, but you can shatter on the side very easily. The next type of fastener I wanted to talk about are just screws. And this is something that I use fairly often in my work, and I know that Bernie does too, so I have a little reference for one of his videos, which I've also put into our work holding playlist. So my strategy for using screws is that you really, really need to be sure of your placement of your screws, because if you accidentally hit your screw with a router bit, likelihood is that the screws or the router bit won't make it through. It'll probably break or chip or something like that. So not really ideal, but there are ways to be really sure about your placement. So what I will do is in my design, I'll plot out safe spots and countersink the locations with a V-bit. And if I just put stop blocks on the side of my material, there's no lateral forces on this, so the V-bit can just tap in the locations of where those router bits are going to go, or where the screws are going to go, and then I can just drill and screw and then run the programs and emit the V-carve toolpath there. So this is, for example, a double-sided 3D carving for, I think these were briefcase handles or something like that for another local firm. So I think screws are something that I trust. The speed is a little bit slower because you have to be really sure and choose to run the V-carve program to plot those locations, that might take a little bit more time. The speed of removal isn't super fast as you have to bring your drill out, but that does sound not too bad either. Cleanup is pretty easy because you're just cleaning up. At that point, you're mostly cleaning up tabs and not the screw holes. Repeatability is easy because you have that program already created. So you can just run it again if you're running multiple sheets of plywood. The initial time cost is a little bit higher because you have to make that program, but the initial cost investment is pretty low. What I will say is that I added a risk bar here because it's slightly, there is a little bit more risk involved if you're not 100% sure about your placement. If you are 100% sure, double check, and then, this risk bar can go way down. So that's negotiable, I suppose. Okay. Oh yeah. So here's some screenshots from Works by Solo. I really like this technique a lot. So in his material, he'll use the table saw or the bandsaw to make a kerf in the material. So this is, I think, like a 3-inch tall, thick piece of oak. And just using the washers and the screws as the hold down. So it has a very low surface area that it's trying to hold down the material, but it is very strong and effective. So I would suggest using that as an option. Here are a few more shots examples that I have where this one is cabinet parts that we were making for a local coffee shop. This is like a fancy custom walnut apple pie. And then just some cutting boards and dishes that I made. And here I am being very precise about where they're located, the screws. And because I'm sure about that and my tab placement, I'm confident in running this program. Here are a few more. I will talk about this one on the left really quick. This is an anodized art piece or anodized aluminum sheet. And when you have that thin of aluminum, it's very difficult to get level. So it's mounted onto a backing board. So I used the screws and wedges to make sure that the backing board itself was level to help adjust the material to be flat in relation to the bed. And here are a few more handles, I think made for a company called Belmont Blankets. And they are, another local Portland business. Okay, so on to clamps. This is a huge category, and I'm going to touch on a few methods. If you have a specific type of clamp that you like to use or something you like to integrate with your T-track, please share that. I'm just going to talk about the basics. This is also something that there's a risk bar I added to this rating because there are some variables here that you can't necessarily plot out in your program. So I would just be really sure about your placement when you're using clamps. So this spoil board in this top picture on the corner, there are holes in the spoil board in order to fit the clamp through and hold the material down. And this is kind of like why I don't prefer to use F-style clamps on this type of spoil board, is because I have to reach under the machine and hook it up. If you have a lot more space under your machine, it's probably not that big of a deal, but there's some other ways to integrate clamps into your work holding in a simpler method. So it is a little bit more risky, but if you take your time to put them in safe locations, draw out on your program or on your file where their safe spots are, and then make sure you put them in those locations, and also set your tool paths to accommodate a safe Z height so it will lift up over the clamp. That's a really another important thing to note when you're using this kind of clamp. Yeah, sheet goods and solid woods. I mean, clamps can be used for many different types of projects. So, okay. This is Frank Howarth's shop. I'm sure all of you are familiar, and if you're not, please go check out his channel, because he is very thoughtful about his work holding. Here are some of his homemade clamps. These more homemade hold down clamps. In this one, you can see he's just kind of pushed them up against the side as having side pressure, but sometimes they do grip over the top of the material, like in this aluminum. Here's a few more kind of close-ups of his homemade clamps. You can purchase them too, but why not make some out of all the scrap material you have holding down, lying around. As you know, Frank really pioneered this vertical holding table that you're able to adjust the angle. And I'm sure you've all seen his really amazing work holding for his bowls and that kind of thing. So he incorporates clamps in traditional work holding with his own DIY design in order to do mortise and tenons and different kinds of joinery and custom bowl fixtures. And so I'm very excited to tell you about this today, because I'm sure you've already seen this video, but Jay Bates, who acquired an Avid CNC recently, he just posted this video today about his spoil board and his vertical table. And I think he's thought through this so well to accommodate the kind of work holding he prefers. So where, I know that Izzy might like to screw down to the bed and just change out the spoil board, every couple months. That is a totally valid way of doing it. And so is this. So kind of figure out what type of work holding and what kind of spoil board and what kind of bed works for you in your practice. I think that's something to think about. So here he's installing these 3/4 inch T-tracks, and then applied these strips in between the T-tracks to kind of raise up the bed there. So T-tracks are another really great solution to integrate into your bed. I'm just going to go back really quick, because here you can see Frank also has T slots here, but those are cut into the spoil board. So he would just use a keyhole router bit or something of that nature in order to cut those into his own bed, rather than using purchased aluminum ones. Also, this is something I really enjoyed about Jay's video, was that he uses bench dogs to line up and make sure the pieces square to the machine. On my spoil board, I also have something similar. I just pot holes and just use wooden dowels. So if that's something, I always have dowels around, that's also a great solution. So making sure your workpiece is square to the machine, no matter where it's located on the bed, it's a really great, easy way to do that. So now I'm going to mention a little bit about vices and fixture plates. There are so many different kinds that you can purchase that are already on the market. Like this, for example, this kind of standard vise up on one of these benchtop machines that we have. There are, a lot of DIY solutions. I will mention that our engineering team is working on some custom fixture plates that will be integrated with our system. You can always add that on to your machine later on. So that is in the works, and we're trying to be thoughtful about how that's being made and designed. So I think vices and fixture plates have a really good place. It's easy to get set up. It's, you have a lot of options to accommodate the different kind of work holdings. So if you're machining block aluminum, like this aluminum dovetail up here, then this might be a perfect solution for you. All right. So here is a shot of Jay's vertical work holding, which I love. This is like my dream work holding table, so I might just have to go make one too. And when we're talking about custom fixtures and jigs, there are so many different kinds, and I think that the initial time cost can be very variable because I can invest as little or as much time in creating a jig as I want to. I can create a 10-minute jig, or perhaps this one took Jay a couple days in order to design, refine, and a couple iterations to get there, which is if you're doing high production or you want it to last quite a long time, then that is something you want to put more time into. So there are definitely single-use jigs for one type of object, and then there are jigs that you're going to want to use for high production or high turnover. So I think ultimately it will save you a lot of time and money later on, but it's something to consider how much time and money you want to invest in it in the up front. So here's some more shots of from Jay's video, which I've also added to our work holding playlist. So you can see here he has his T-tracks installed. He got an extra leg set to install. That's the extrusion behind this, so it's integrated into the machine frame, and he has all these different angles, so we can change the angle of the part. You can put clamps through it. You can use this cam style clamp, or just the traditional hold down clamps like these Rockler ones up here. And really utilizing the touch plate as a powerful tool to make sure your work holding is square or level. That's another thing to consider in your creation of your own work holding. Another really fun video that just warmed my heart this week was JD's project from Rainfall Projects. If you're familiar, also go check out his channel. Go watch this video after. He made this 60-inch bowl, which really pushed the limits of his gantry height, which was awesome because we want to see the machines push their limits, And he made these one-time single-use jigs where they had, just made of plywood. They don't really have much, they're not very applicable to future projects, but they're still worth making. So this is just 2 pieces of plywood slot together. And then you can see the one for holding it when the scoop is facing down and when the scoop is facing up in order to do that 3D carved shape. So I think that some time investment, even for a single use work holding, is a really great thing to think about. It also helped him it turned out to help him with the glue up also, so it can have added benefits that you might not foresee. Here is another kind of vise for a very specific project. So we made this work holding for, we made, I don't know how many speakers we made, but this was for the Autodesk University a few years ago. So these little Bluetooth speakers, and you can see, I don't have any pictures of it before the middle was carved out, but basically there is a long piece of the hard maple, which is being held on the ends. The interior of the speaker is engraved and removed, and then the sliding, I guess this would be called like a straight action clamp or whatever kind of clamp it is called. It's holding down each individual part as they're being cut and separated from each other, so to really reduce the amount of material that is removed. So here we aren't wasting any material on the top or the bottom of the speaker, just kind of removing the 1/2 inch in between each part. So reducing amount of waste is also something to be thoughtful about. You can see there's more time and a little bit more money invested in this because we have bearing blocks and linear rails integrated in a very Avid CNC type of way. So this is a project you might invest more time in, but it will be ultimately worth it because you have so much turnover. Here's another kind of work holding I did for a friend and I did for Jacobson sea salt displays. This is kind of like a weekend project, but we had to cut, 500 of these beams. But because it was in a local makerspace, I didn't really have too much time to build a whole custom fixture. So we just used clamps to hold down extrusion to the bed to make sure that was square to the machine, and just running the spindle with a dowel in it to make sure that it was square the whole way down. And you have to kind of consider any variation in your material, if there's bows or length variation, because of course the beams we were brought were not all the same length. And they will all have to be perfectly cut with the right size kerf of blade to make these into individual displays. So, if you invest more time into your hold down and your work holding and your vise, or your custom fixture, you can really maximize the yield and your cost per item or cost per piece, which ultimately helps you make more money, right? So, okay, so on to live edge, slabs, and leveling. There's lots of different ways to do this. I'm just going to talk about few simple things. It might vary depending on if you have an MDF bed or if you're just putting the material onto extrusion or into your cross members. So for example, here is like a wood cookie somebody brought in and just wanted leveled. It is kind of difficult because usually both sides of the cookie are cut with chainsaw, so neither are pretty level. But using stop blocks around the edges of the material to make sure that it can't move or slide on the bed, and because there's not too much because the material is pretty thick and heavy, I don't necessarily have to worry about it lifting up, like you might with a 4x8 sheet of 1/8 inch acrylic or something like that. You really have to worry about the lifting up. But with this, you don't have that working against you. So I think it's a super cost-effective way. I'm just using some scrap material, screwing it down. Because I'm trying to level the whole surface of the material, I don't have the ability to hold down clamps, so you have to kind of consider and be a little bit more creative there. Here's some references from Canadian Woodworks. You can see they just have strips of MDF on top of the extrusion, and they'll just place wedges that are clamped here along the piece in order to level it, because these are kind of flat, but there might be some teeter-tottering because it's not perfectly flat, or when it was pulled out of the kiln it might have cupped a little bit. So this is another way to accomplish that, is using wedges and then side reference edges. Here's another type of work holding that you might come towards you, because this project I had to engrave a scoop into, I think this is walnut, but I'm not sure. So if you're really good at identifying wood, please let me know. This project was a long time ago, but it was a scoop into a live edge, so it's something you really don't want to make a mistake on. But you can see here, this was just drawn on with a raw pencil line, and they said place a scoop around here. And I have a little bit more areas where I can use clamps or hold downs because that's not where it's going to be engraved. But you do have to be very thoughtful about how you zero. So in this case, you might zero from the cross members or the crosshairs in the center of where your scoop is going to go, because there's no square corner to reference off of. Oh, hey Jay, thanks for joining. I just talked all about your video earlier, so hopefully everyone goes to watch that afterwards. Okay, so that's something to consider for different styles of live edge machining. Sometimes you're given a challenge, which is something that's a little bit more organic, something that has no square edges or flat surfaces, like at least the live edges are flat on one side, hopefully. But for this piece was a friend of mine, Ellen, makes stacking rocks and mandalas, and she really wanted this rock to sit in the burl. And I considered a couple different ways to hold this. I could put it in the rotary, but it doesn't really have a square end for the jaws to clamp to. And sometimes you can kind of just cowboy it, you know, and that's really okay, because if it's a one-time single use work holding for something that's really weird and organic, that sometimes that works best. So I'll show you what I kind of came up with here. Was I just screwed a bunch of scrap material to the sides to hold it from moving, to kind of keep it holding upright, and then some plywood that kind of can bow over the edges of it. I was also thinking too, if I had still had those holes for the clamps in the spoil board, I could have used ratchet straps or something like that, or maybe installed something like that would have been a really alternative solution. So just trying to be really creative in your work holding is you know, giving yourself challenges like this, something that's not flat, something you can't, don't know exactly how to reference. Okay, so I'm going to touch on rotary pretty briefly, because it is technically, right, a kind of work holding. It does add a fourth axis capabilities, which are, you know, a lot of things that are easier to accomplish on the fourth axis, you can still accomplish in 3 axes. You know, for example, if you wanted to index a part on the top, the side, and the bottom, and cut different things, you can create work holding to, and then physically rotate the part and run the different sides. And this just does that for you. I will say there are, it's so dynamic, you can accomplish so many different kinds of things with it. But obviously, yes, it is a higher initial investment in cost, and it does require some more advanced cam skills. So obviously do consider that, but if it's something you're interested in, I really would encourage you to take that step and to learn about rotary, because it can add so much capabilities to your machine. And this is has a 10-to-1 planetary reducer. It's a really strong for holding your workpiece. This hard maple block is, I think, 8 inches by 5 inches by 30 inches. So it's a very heavy piece of material. So it's very strong. I will say that typically, you know, cleanup isn't too bad. You do have to remove these sections on the end. Usually not too much of an issue. Cleanup's usually pretty fast unless you're cutting a pumpkin. So that will add some cleanup time to your project. So that was all my presentation. So we can get into some questions here. So I'm just going to mention a little bit about Avid. You know, we are a manufacturer of very professional machine tools, and they're very exceptional value and affordable compared to many products out there, but really perform well for you. And another one of our goals is to make them accessible to everyone, and that's something that we're really working on with our education. We're working on developing an online CNC curriculum, Intro to CNC, so really anyone new who's getting to it or wants to strengthen their foundation, hopefully I'll have that out there for you soon. So if y'all have any questions or other things I can answer, I'd be happy to do that now. Oh, hey, Narwhal Labs, what's up? Thanks for joining. So I have some questions from our Instagram earlier. So how to deal with soft plywood like poplar to get nice edges. So I think this question might be referring also to get nice edges. Okay, so router bit selection has a huge part of that. I would also recommend putting foam on your clamps, on your work holding, or scrap material between the clamp and your workpiece. Best ways to get it set up with the CNC on a small budget. Well, that's a great thing with ours, is that their kits, our machines, are expandable. So if you want to start with a 4x2 machine, you can, and then expand it later on. To add length to your machine, you would want to establish the width at the beginning, but you can add length later on. So you can start with a 4x2 and then turn it into a 4x8 or whatever you like. Cool. I see that there's some questions about vacuum table. Yes, this is definitely something that we're aware of. Let's see when this question's coming in. When to use them. So when might we choose to use a vacuum table? This is a great question because it does have a place. It's not a perfect solution for every type of project. It works better on larger format things like cabinet making when you're cutting a sheet of material and your pieces are larger than it's about 1 square foot is the ideal, the smallest surface area that your part is, depending on the vacuum system you're using. So I would use it on larger format things and more with sheet goods or solid woods. And it's not necessarily the perfect solution for every kind of project, and they can be very loud and cumbersome. So this is something that our engineering team has been working on refining and creating an integrated system that works really well. It's modular and works for more than the normal 4x8 vacuum table that's going to be really loud. So we need to make sure that it's working for many different types of customers and people who are using a smaller machine versus someone using a larger machine, or you only want a section of it to be vacuum. So great. Let's see, there's another question here. Running a dowel down the project. Can you elaborate? Okay. Yes. So one thing to consider when you're trying to make I'm going to switch to my camera here so you can see me. I'm going to use my pen here, very visual. Here's my bed, and here's my spindle. So I could put my material anywhere I want on the bed. It can be diagonal, it can be sideways, but I really want it to be parallel to the bed. And how do I accomplish that? When I don't really have any reference points, Jay solves this issue when he puts the bench jog holes because he knows those holes are square to the machine. Or if you plot a bunch of holes after you rough all homes, and then you can drill your holes to make sure that those are square to how your machine is set up. Alternatively, if you don't have your spoil board set up like that, if you have your spindle with a dowel in the spindle, or a router bit would be fine too, towards the front of your machine, and then you move your material up against that edge, and then you would not attach this material yet. You might mark the corner with a pencil on the spoil board, and then drive your spindle backwards, and then butt the back corner up against it. So now we know that the spindle or the material is square to the bed or to the gantry, because we're just moving the spindle in one axis. So then we can just rotate the material to fit that line. Cool, let's see. Any other questions we've got here? Okay. Hey Ty, how's it going? Good to see you. Hey Pete, what's up? Cool. Okay, nylon bolts, that's a great solution too. Super safe to use. Awesome, that's a really great solution. I like that. Cool. Any other questions here? Corey's might have one for me here. Great. Well, thank you all so much for joining me. Stu says we're looking forward to some plasma videos soon. Yeah, hopefully soon. There's a lot of updates that we're bringing to plasma, and we're really trying to refine those updates, especially with Mach 4 and cleaner integration with that. So I hopefully will have a plasma video for you soon. Cool. I think that's all of our questions. Thank you everyone so much for coming. I really appreciate getting to spend this time with you and getting to talk about work holding. So I will see you all soon. Next week will be a Mach 4 talk with Corey, and looking forward to that. If you all have any other live stream ideas or questions, please feel free to email that to support, and we look forward to seeing you all again soon.